Welcome to this lesson on the lens equation. This is one of the most important formulas in optics that helps us calculate where an image will form when light passes through a lens. Understanding this equation allows us to predict image positions mathematically, which is essential for designing optical systems like cameras, telescopes, and eyeglasses. Here is the thin lens equation. 1 over f equals 1 over do plus 1 over di. This powerful formula relates three key quantities: the focal length of the lens, the distance of the object from the lens, and the distance of the image from the lens. When you know any two of these values, you can calculate the third one using this equation. Let's understand what each variable represents. The letter f stands for the focal length of the lens, which is a fixed property of the lens itself. The symbol do represents the object distance, meaning how far the object is placed from the lens, and di represents the image distance, which tells us where the image will form relative to the lens. To use the lens equation correctly, we must follow sign conventions. Positive values are used for real images, converging lenses, and positions to the right of the lens. Negative values are used for virtual images, diverging lenses, and positions to the left of the lens. These rules ensure consistency and help us interpret our calculated results correctly. Let's work through an example problem. We have a converging lens with a focal length of positive 20 centimeters. An object is placed 30 centimeters from the lens. Our goal is to find the image distance. This is a typical problem you'll encounter when working with lenses. We start with the lens equation. 1 over f equals 1 over do plus 1 over di. Next, we substitute our known values. 1 over 20 equals 1 over 30 plus 1 over di. Then we rearrange the equation to isolate 1 over di by subtracting 1 over 30 from both sides, giving us 1 over di equals 1 over 20 minus 1 over 30. Now we calculate the right side. 1 over 20 minus 1 over 30 can be rewritten with a common denominator of 60. This gives us 3 over 60 minus 2 over 60, which equals 1 over 60. Taking the reciprocal of both sides, we find that di equals 60 centimeters. This positive value tells us the image forms 60 centimeters to the right of the lens, and it is a real image. Let's review the key takeaways. Use the equation 1 over f equals 1 over do plus 1 over di to find image positions for any lens system. Always apply the sign conventions correctly to ensure your answers make physical sense. And remember to rearrange the equation algebraically to isolate the unknown variable you're solving for. With practice, this equation becomes a powerful tool for understanding image formation.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.